It's a hot topic. I can tell by how full the room is. One of the great things about Adam, he's been with DEF CON in one way or another, or Black Hat, since it's been along. Mag stripes, you want to talk about hard technology hacking, adjustments, it's this man. We're pleased to have him. Black Hat, just fascinating stuff. I hope you get as much out of this lecture as we all do. And hey, here's Adam. Yeah.
Thank you very much. Thank you for coming. So yeah, my name's Adam Laurie. I'm also known as Major Malfunction over at DEF CON. Not because I'm an evil hacker and I'm trying to hide, but actually in the early days, I've been doing this a long time, as you said. I did DEF CON 5 originally, so I've been doing this about 10 years now. And in the early days, people used to get in trouble for going to hacker conferences. So I used to go under my handle, which was actually a gaming handle. I'd never been a hacker. So Major Malfunction is a gaming handle, not a hacker handle. I'm a good guy. I'm just misunderstood. So, but yeah, I mean, people were actually getting sacked. In the early days of DEF CON, people were getting sacked. And it was only when I started speaking about 3 years ago that people found out that Adam Laurie was Major Malfunction. There were a whole load of goons over there I've been working with for years, and they're like, oh, that's who you are. Okay. So they only knew me as Major. But so a little bit about what I do. Most of my research at the moment, you might have known or heard of stuff I did before on Bluetooth. That's all been published on trifinite.org. My current obsession is with RFID, and I publish an open source library called RFidiot, which is on rfidiot.org, and you can find all that stuff. Every tool I'm going to use today, and I'm going to demonstrate to you, is freely available and downloadable from the RFidiot site if you're interested in playing with this stuff. So, in more detail, what I do, until January, was the technical director of a hosting company called The Bunker. We take over ex-military assets and convert them to civilian use. We have nuclear bunkers in the UK, which we use for secure hosting. But I spend too much time having fun at conferences and playing with toys, so I can't hold down a steady job. So I'm now a non-exec. So I'm still involved in the business, but I'm not involved day to day because I'm just not there often enough. So I'm now a freelance. I do weddings, bar mitzvahs. If you... me and my brother, a long time ago, published Apache SSL, open source secure web server. As I said, I'm a DEF CON goon. Do a lot of research. Everything I do, I publish open source. And yeah, I'm available to talk to if you've got interesting projects. So a specific thing that I do. I like to look at technologies from a different angle, if you like. And I quite often find things that are broken in funny ways. And I'm actually going to show you a video of some hardware that I came across when staying in a hotel. And there's actually several points to this video. One is talking about computer law and normal law and criminal law and so on. We have an issue in the UK currently, which is they've changed the Computer Misuse Act. So it used to be illegal to attack computers or to break into things. Now they're saying it's also illegal to produce the tools that might be used to attack computers or break into things. But then you have the issue of dual-use tools. So what happens if I produce a tool that's actually useful to the security community, but it's also useful to the evil hackers? Well, apparently that's taken care of. If it's more likely to be used in a crime than a non-crime, then you're a criminal. And if not, then you're okay. But how do you know? If you've just published a piece of software, how do you know what it's going to be used for? I have no idea if you're going to go out, take this software which I've written with the best intentions, and go and rob banks with it. I can't tell if you're going to do that. If you do, I want my cut, obviously. But so, you look at something like Nmap. Nmap is a very useful criminal tool. It's also a very useful security tool. So part of this demonstration was, well, what if you applied the same logic to the physical world? If any tool that could be used in a crime was, the manufacturer of that tool was considered a criminal, would we be locking up people who make multi-tools and paper clips? Because that's what I'm going to use to perform a research act in this next video. Okay, so I've got a little video clip I'm going to play you. Before I play it, I need to ask some questions. I have a competition. When I speak on Bluetooth, there's a couple of other speakers I normally speak with, and we take it in turns to be the lead speaker. And we have this sort of rolling competition to see who can get the most hands raised in the room. And you're not allowed to just say, raise your hands, because that's lame. So it has to be a relevant question, relevant to the thing you're talking about. So I've come up with one which I think will give me a good chance in this competition. How many people here, stick your hand up if it applies to you, have ever stayed in a hotel? Excellent. Okay. How many people here have ever used a hotel safe? Okay, keep your hand up if you think it's secure. Okay, only one of you thinks it's secure, and yet you all use it. That's strange in itself. Okay, so this is a little video. I stayed in a hotel recently in Miami at a security conference, and it was a brand new, state-of-the-art hotel. And I was thinking I'm going to have some really cool toys to play with, RFID keys and all that stuff. I was a little disappointed they're still using magstripe. But since I've got toys to play with that stuff as well, I wasn't that disappointed. But in the room we had a safe, brand new, state-of-the-art safe. So I'm actually doing some research on hotel safes. And since I was at the conference, I thought, well, I'll give you a quick preview of some of the things I'm finding. So I had a look at the website from the manufacturer, and they have a lot of sort of flowery text about how wonderful their safes are. So I had someone from the audience come up and read the page. So I've actually put the voiceover onto the video, which I'm going to show you now.
Through the past 3 decades, we have developed the largest line of in-room hotel safes in the world, specifically designed with the particular needs of the hospitality industry in mind. Our safes are available in a wide variety of dimensions and colors, with either electronic or mechanical locking systems. Manufacturer continuously researches the development of new features, functions, options, and designs for its products. From removable core locks to a variety of electronic systems with digital keypad, credit card readers, or chip cards, manufacturer offers you products in the forefront technology. Our safes are installed in the most prestigious hotels and cruise lines throughout the world, which have recognized manufacturer for its quality, warranty, and superb technical service. Our uncompromising pledge of satisfaction to the client
So apparently that's uncompromising quality. If you ever get your minibar and your safe mixed up, you know who to come to. So who's the criminal there? Me or the guy who made the paperclip or the guy that made the safe? I can't work it out. Okay, so on to the real subject, RFID. There's several talks here about it, and a lot of the speakers are going to speak about the more detailed, low-level technical stuff. I'm not going to talk about how it works at all. I'm not that sort of level hacker researcher. What I tend to do is just look at the applications, find ways that people are using it in silly ways, and maybe the way the technology is being configured or used gives me some kind of opening. So I'm going to talk about trying to use the technology against itself rather than trying to defeat it by creating other technology. But one of the things that is worth understanding is RFID is a bit of a misnomer. A lot of devices, contactless devices, are not really using radio. They're using, in most cases, the low-frequency stuff. They're magnetically coupled to the reader, and they basically mess with their antenna to ground the antenna and mess with the field on the reader. modulate that, and the reader then sees that it's got a signal. The reason that's worth understanding is because it affects how far away you can attack things from. You know, you can't sit right back here with a massive antenna and expect to see a tag at the other end of the room, because you actually have to deliver the energy to the tag to wake it up and so on. There are people who are working on long-range stuff, but that's not one of the things I play with. So in general, there's two types of RFID tags. The dumb ones that just spit out an ID, possibly some data blocks, and the smart ones where there's actually some onboard processing. You can have a conversation with a crypto processor, do authentication and so on. And those tend to be used for payment systems. And, of course, the new biometric passports, which we'll be looking at specifically. So what kind of things are the dumb keys being used for? One of the very early applications was animal ID. We're now seeing them in hotel keys, car immobilizers, obviously. Can you switch your phones off? I have a rule. I run the DC 4420 group, and we meet once a month and we speak. And we have a rule that says if your phone goes off, you buy the speaker a drink. If your phone goes off twice, you buy everyone in the room a drink. So it could get kind of expensive. Yeah. So, yeah. If you spot someone's phone going off, mark them so we know that when... There we go. Guaranteed, one in every crowd. Okay, and on the luggage handling, they're starting to do that. Various airports, Heathrow are just about to start a trial. So, yeah, some interesting tags going on out there. Human implants is something I'm going to be touching on specifically as well. And we'll look at those today. Is there anyone here who's got a tag implanted? Implanted? It's not in there yet? I can help you. Okay. No implants here today. All right. Never mind. We've actually got quite a lot of time, so if there are people here with tags, we might do a little live workshop at the end if we run out of questions. Okay, so implants. This cartoon caught my eye, and I thought it summed up the situation quite nicely. Although I have to say, you'd have to give me a hell of a lot more than an MP3 player to get me to bend over for one of those. But, apparently this guy wasn't so concerned. The guy on the top is a radio DJ, and he's doing a story on a beach in Spain where all of the vendors along the beach, the bars, the ice cream shops, the restaurants, and so on, use a digital wallet system. And you have a chip implanted, and that's then connected to your digital wallet, which you top up with credits. And it's kind of a good idea. You can go to the beach without worrying about your wallet being stolen because you've left it safely in the hotel safe. I like that beach. I go there a lot. The guy on the bottom is a Mexican official. He is working for the Mexican government, I believe, and they're now putting access control systems in, which basically require you to have a chip before you can get into a particular part of a building or area. He does look a little concerned. The reader is recognizably a reader from a company called Verichip, and we will talk about them specifically as well. So the whole premise of these dumb systems is the chip that you've got implanted is unique. Absolutely cannot be cloned, guaranteed. As we all know, there have been several talks where people have produced cloning devices. So that's just simply not true. You can clone a tag. That isn't chopped off. That is the full URL there. .pl, I believe, is the end of the URL. But this is Jonathan Westhoose's device, which he demonstrated last year at DEF CON. That will clone a Verichip, I believe. It was Verichip standard. The circuit diagram, all the software, all the component parts are on his website, and it will cost you a grand total of about $20 to build that thing. Bit of work. It's a double-sided circuit board, and you'll have to burn that yourself. So it's a bit fiddly, but nothing you can't do over a weekend. So when someone comes up with one of these things, there's always an industry response and a defense. So I like to imagine after last year's talk at DEF CON, some techie who was there, some poor little geeky kid in the company, comes back to the company and says, "Oh my God, it's game over, they're cloning our tags." And the executives are like, "No, don't worry, we'll come up with a solution." So this is what they came up with. That doesn't look like a tag. We're fine. Don't worry about it. Nothing to see here. Second line of defense. If you have patent attorneys, you could always talk to them. HID versus IO active. I'm not going to say anything too specific about this in case there's anyone from HID or practicing patent attorneys or any other kind of attorney in the room. But basically, IO active were going to give a talk about HIDs, and then they didn't. And there was some discussion between the two companies, which has been published. So if you're interested in reading that, I believe they've now kissed and made up, and IO Active are talking here or have already talked. I'm over at DEF CON, so I'm not kind of keeping up with what's going on. But that should be a very interesting talk if it hasn't happened yet. Do you know if it's happened yet? Have a look in your program. IO Active, Chris Paget, I think, is going to give the talk. So anyway, bottom line is the actual reader can't see the tag, so what it physically looks like is utterly irrelevant. So if you do a bit of research, you'll find that Jonathan Westhouse's device and Chris Paget's alleged device, which may or may not exist, I cannot confirm or deny, isn't unique. I mean, there's loads of them. You go out there, there's a bunch of these things. And this last one on the bottom right-hand corner is a project on Circuit Cellar over the weekend, do your own RFID system. But that's okay, because none of them look like tags. So nothing to worry about. You're all safe. So I took that as a challenge, because I like a challenge. So my challenge was, can I bypass this whole argument and produce a true clone? One that has the same ID and actually looks like the original. Exact same form factor. So in order to do that, I first have to understand what does the ID consist of? The thing with these circuits that are playing them back, they don't have to understand that. You can just record the signal and play it back, and you really don't need to know how to construct it. But I wanted to understand exactly what the underlying signal was, or the data. So luckily they use industry standards, so I can just take an industry standard example and have a look at how it's constructed. So I looked at animal tagging. They use, in the UK and most of Europe, and I think parts of the US, they use ISO 11784 and 5, otherwise known as FDX A or B. I'm going to look at FDX B. That gives you 3 fields. An application flag which says it's an animal product or not, 3-digit manufacturer or country code, and then the national ID. And the national ID is issued by the country or the manufacturer. So the tag and the reader will successfully communicate. The reader will be able to read the tag if a tag comes up and follows the right parameters. And those parameters are, it's going to talk on a particular frequency, so the dumb tags tend to be 125, 134. Smart tags are these days mostly in the 1356 range. They'll talk at a specific bit rate, which is the frequency divided by some factor of 2. And then it will modulate the signal according to a specific standard, like FSK or Manchester biphase, whatever. And then, of course, you have the actual data pattern. So if we look at the raw data that I get out of a dumb reader that's not trying to interpret it, I'll get 8 bytes. And that's divided up into a national ID, country, and application code. Very simple, just take this chunk of the bits, this chunk, this chunk. You then have to tweak them slightly, reverse the nibbles, and so on. So I put into the slides, for anyone who's that interested, they can follow this, exactly what's happening to a particular ID. So we take that top line, that's the ID I get, turn it back to front, reverse each nibble. And there I have my application ID, which says 8,000, I'm an animal. Country F65, left shift that, right shift that, turn it into decimal. You can then look that up in a database. So it's either the ISO standard country code, or if it's above 900, it'll be the ICAR.org name. And in this case, the example I looked at is Digital Angel, who now are known as Verichip. And then you've got the national ID that they issued. So obviously, if I can decode a signal, I can encode a signal. I just reverse the decoding process, add the headers, add the checksums, and so on. What they do here as well is this header is all zeros. So in order to make sure you don't accidentally get a header repeating in the bit stream, you chop it up into 4-bit chunks. So this header's, I think, 9 bits long. You chop it up into 4-bit chunks and put a 1 in between every 4-bit. So you can't possibly have 9 zeros in a row. And that's just to stop it. That's just so it knows where in the bit stream it is. Because all that happens, you stick the tag in the reader wakes it up, and the tag will just start barfing out its number, and it will just keep doing it. As long as it's energized, it will just go blip, 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 blip. So it looks for the header to find where the beginning of the stream is. Okay, so now after we've done all that, we end up with 128 bits of data. But how do I deliver that? Remember, I'm trying to do it in the same form factor. I don't want to be building any circuitry, trying to make my own little plastic cases and stuff. So I want to use the technology against itself. So I thought about the industry, and I thought about the manufacturers. If I was a manufacturer and I'm working in this industry that's exploding, there's a plethora of new standards coming out, what would I do? I would build some kind of super tag that I could just program to be the standard that I want to be. So, the frequency is the same. You've got a few different parameters that I need to set. It's going to be much easier if I have a device that's capable of doing all those different parameters, right? So if I can think of that, someone in the industry can too. And sure enough, I looked around, and there's a couple of devices that match that. There's a thing called the Q5. The Q5, you can program each of the individual parameters. So you can set what bit rate to use, what modulation it's going to use. It's got 224 bits of user programmable memory, so that's plenty of room to put my 128-bit data. And I can tell it how many blocks to spit out when it wakes up. The other approach is you have categories of parameters sort of stuck together, and the Philips High tag follows that standard. So they have 3 different formats of tag, or of behavior, and they call them public modes. So A, B, and C, and I believe A is animal standard, B is door entry systems, and C is car immobilizers. Typical use for that particular family of tags. And again, I can program some data and tell it how much of that to spit out when it wakes up. So as far as sending the ID goes, I had a bit of luck. I was working in a shared office building, and I had a tag. And when I started playing with this stuff, it turned out my reader was telling me this was a Q5 tag. So in theory, I can reprogram it. So as long as I can figure out the bit rate, the modulation, whether I need to invert the data, and so on, I should be able to reprogram this tag to behave the way I want to behave. So that's what I did. So I'll give you a quick demonstration of cloning a tag called a Trovan Unique. This is a brand that's very commonly used in access control systems, human implants, animal implants. Some people are implanting them in themselves. And as I said, if you're interested, I've got the bits here. You might not want one of those stuck in you, but if you do, come and see me afterwards. I've got some tags as well. But anyway, I'm going to show you reprogramming a tag to be a Trovan tag. So I have here a door entry system, which looks like that. And actually, this is interesting in itself. How many of you flew here? Raise hands, most of you. Going through security these days is quite fun, right? When you have something like this in your hand. So I tend to carry that in my hand luggage because I suspect if they scan my normal luggage and see that, you know, it's got a little battery, it's got a controller, it's got some wires and things, I might be hearing a sort of muffled crump around the back of the airport, and that's my luggage blown into a million pieces. So I carry it with me so I can explain what the hell it's for, and I can demonstrate it. And on one trip coming through security, I was directly behind a couple who had a newborn baby. And they had a whole load of luggage, and they had the pram, and they had everything with them, the kitchen sink. So the lady goes through, she takes the baby through, and the pram goes through, and all their luggage and their crap goes through. And the last thing that's left behind was a box with 6 bottles of milk in it. And the guy screening the baggage says, well, you can't take fluids on board. So the father's like, well, I have to. You know, we're going on a 12-hour flight, we've got a newborn baby, I've got to take the milk on board. So he calls his supervisor over, and the supervisor says, no, that's okay, we can make an exception for the milk, but you have to prove that it's drinkable milk. 6 bottles of baby milk. The father's like, okay, so he's got to taste each one. And I'm thinking, what kind of milk is that exactly? But he obviously loves his wife, and he tastes the milk, and it all goes through okay. What they get up to on their own time is, it's nothing to do with us. Who are we to judge it? Anyway, the milk goes through. By this time, there's quite a big crowd has built up behind, and everyone's getting impatient, and I'm standing there. And we've now got 3 people behind the desk. So we got the original guy who was doing the stuff, we got the guy who looks at the screen, and we got the supervisor. And they're all standing there, and they look, this is all gone, and they look up, and there's the picture of my bag. And it's got wires, and it's got batteries, and it's got all sorts of crap. I mean, this is nothing, what I've got on the desk here, compared to what I've got down there. And so I'm thinking, okay, floor, swallow me now. There's going to be trouble. Big crowd of people behind, wondering what's going to happen, and they're all looking at it, and they're looking really intensely at the screen. And then one of them goes to me, there's no fluids in there, are there? So that's okay, you can bring your bomb-looking thing on board, but as long as it's not liquid. No, okay, fine, on you go, run along. So, crazy times we live in. So anyway, my door controller. So what I've done is I've hooked it up. This would normally actuate the door. I've got a little red light, so if I put the correct... Can you see that at the back? Is that lighting up for you? Yeah. So this is the correct door tag. I do that, the light lights up. This is my other office door tag. Do that, nothing happens. So I'm going to try and reprogram this to pretend to be this. So to do that, I first need to get its ID. And somewhere. Okay, this is a sort of cheapo, it's called a keyboard wedge, so it reads an RFID tag and it just spits out the number as if you'd typed it on the keyboard. So I'm going to whack that into a shell quickly. I just need to check it's configured for the right speed. Can you read that at the back? Okay. So what I'm going to use to program it is an off-the-shelf. This is actually a demonstration reader produced by a company called ACG. Generally they don't make end-user products. They make bits for systems integrators. But if you are sufficiently interesting to them, you're an integrator or you're producing software or whatever, they'll send you samples of these. So I emailed them saying, look, I'm doing this RFID open source library and millions of people use it and you'll sell thousands of bits of hardware. And they're like, okay, have one of these. So they sent me a couple to play with. After I published RFID, I got a very terse note saying, RFidiot, sorry, I got a very terse note saying, your activities are contrary to the interest of this company and we will no longer support you. So, apparently secure RFID is not on their agenda. But never mind, I can buy the bits now. I've got the manuals, I know how it all works, I don't need them. Screw them. So it's a compact flash card, I just whack it in a PCMCIA adapter. So if I now present this tag to my little keyboard wedge, it'll give me the ID. So that's the unique number of the tag. Okay, only one in the world at the moment. So, sold under the brand name Unique, so I wrote a little program called Unique. Tell it I want to write it. It's waiting for a blank. Put the blank down. Do you want to write that? Yes. Done. So if I now hold that up, if I got it right, I should be in your building. I love it when a plan comes together. So yeah, you could palm that, walk past someone, stand next to them in an elevator, just get access to their keys for a couple of seconds, you've got the ID, they're owned. Okay, so the other demonstration I was going to do was cloning an animal tag. We use these a lot. I live in the countryside. We use them in farm animals and stuff. So I was going to bring my cow Daisy along, but she got stopped at Heathrow at the security desk. Something to do with fluids. I don't know what it was. They wouldn't let her in. So I've got my little mouse friend here, who I've brutally implanted with a tag in her place, sorry. If you give me a second, I have to set up for this as well. Okay, so this is a standard scanner you would find in a vet's surgery, whatever, for scanning animals. Incidentally, when I got this, I have a pet dog, and she had a tag implanted in the back of her neck. So when I got this, I thought, I wonder, if hers is the same standard. I wonder what the tag number is. And I scanned it, and I couldn't find the damn thing. I thought, okay, it's not the right standard. And a bit later, when I was more confident that I knew what I was doing, I scanned her again, and I eventually found it, and it was here. Okay, so they put it in here. It's now just above her elbow. So if you're thinking you have one of these implanted, think carefully about where you start, okay, because these things travel. Could get uncomfortable. Okay. So I can whack this into a serial port so you can see what I'm doing. Just quickly. Okay, readable at the back? Yep. Okay, so if I hold up my little friend and I press read, it pops up. So that's telling us it's an FDXB, country code 968, that's the unique ID. Okay. So just to show you I'm not cheating, if I scan this one, as it stands, it'll come up with the code of the unique, also known as EM4102. So a completely different code. So I'm going to reprogram this tag to be the mouse's tag. Actually, I have to reset it. When I first started doing this, I pretty quickly, you know what it's like when you're playing with something new, some new hardware, and you start thinking you know what you're doing and you tweak it, you eventually break it and it stops working. So I very quickly got to a point where I not only couldn't clone tags anymore, but I couldn't get back into my own office building anymore. So that was a bit of a hurdle. And I then found, okay, I can obviously just buy some of these. So I bought 10 of them, and I started playing with those instead. And eventually I'd bricked all 10 of those as well. And I was on a train on a really long journey on a business trip, and I had plenty of time to play with this stuff. So I thought, okay, I'm going to really focus and fix this. And I did actually eventually come up with something which helped me out. So I wrote a program. And it works too. Okay, so that's now reset the card back to its original state, so I can reprogram it. But actually, again, we're going for same form factor. So I'm going to actually reprogram an implantable chip. So you've all seen the James Bond film, right, where they just put a thing around his wrist and press the button, and he goes ow in a kind of manly Bondy way, and he's got a chip in his arm. Doesn't work like that. They strap you down and they stick one of these bastards in you. So I have one in my wrist, which I'm now going to reprogram to be the mouse. So again, just to show you I'm not cheating. Reading. Wow, that's good. I killed something over there. Okay, so it's not reading, right? So what I'm going to do now is I have another program called FDXB. 8,000, because I'm going to be an animal. That's just the timeout. Do I need to scan my mouse again so I can see what I'm doing? So country code 968 and this guy here. Okay, I probably have to reset the one in my wrist. So if you go back to the screen, remember that number, 470-897, 8897. What do we do? Control A, clear. So if I now scan myself again, I am that mouse. Very good. Can you spot the difference? So finally my wife is right, actually. Okay, so as we can see, that unique they are not, potentially. Verichip, I'm not going to actually demonstrate a Verichip because I don't have one that has the right attributes. When I asked if someone was implanted here, I was hoping that someone was. I guess DEF CON's probably a better place to look. But Verichip are using this standard, exactly the same standard. It's already well known in the industry that you can do this. So there were concerns about, how secure is that going to be if you can produce a chip with the same ID. So Verichip came up with a fantastic, brilliant scheme that will stop anyone from being able to clone their chips. This is a 3-digit country code, right? Verichip go up to 4. Ooh. So their code is a 4-digit code, and commercial software for producing these chips cannot enter 4-digit code, so you're all safe. Nothing to see here. My software, of course, doesn't give a damn. If I put in 1022, which is Verichip's code, it will program a tag to have that ID. Okay. They may have other mechanisms, I don't know. I'm quite keen. If anyone knows anyone who has a son or a daughter that's chipped, and they're going to DEF CON, please ask them to get in touch with me. I'd like to try it. I'm 99.9% recurring sure it's going to work fine. So the obvious threats from this kind of stuff: if you have an implanted chip, then you can obviously be tracked, and if you can be tracked, you can be targeted. You can be impersonated, as I've shown. I could change my implant to be your implant and go and spend your money on the beach. Not only the stuff in the hotel safe, but the stuff down at the billing system. So that's obviously bad. And actually, if you think about it, impersonating someone works both ways. I can impersonate someone to prove they were somewhere that they weren't. So if we were to start using these in like probation environments where somebody has to go and prove that they are, they haven't fled the country or whatever, I could take over their tag ID and go and present myself at the police station for them while they're up down the road robbing the bank or doing whatever they do. I don't know these people. They just give me money and I do stuff. So. And of course, the other, if we want to use the T word, smart bombs that only go off when a certain type of person or a certain number of people have walked into the room. That's low frequency stuff. Before we move on to high frequency, do you want to do a quick question and answer session on this while it's still fresh in your minds? The chip in my wrist is a Q5, yeah. You can get high tags in that form factor, though, if you wanted. I'm lying. It's in my watch. Okay, I'm crazy, but I'm not that crazy. It is one of the implant glass tags, but I've just sewn it into my watch strap, which is a lot less painful than the real thing. So, I did try with the real one. I didn't get very far. Yes, sir. The question was, have I played with looking at the readers themselves? I haven't directly. I have been in communication with someone who's taken one of these apart and has figured out what EEPROM is on there and so on. They are software flashable, so you can get upgrades and flash upgrade them. So he's pretty close to having pulled the firmware, and we're then going to disassemble it and have a look, because at the moment, if I present a tag to this device, even if it's the right frequency and everything's cool and it's receiving data, unless it can interpret that bit stream to the right standard and all the checksums work out and so on, it won't actually ever give it to me. What I would like to be able to do is reflash this to be a general purpose reader that will just give me the raw bits that are coming off the tag and tell me what modulation it's using, what frequency it's running at, what the data rate is, and so on. That would be a really useful thing. As I mentioned earlier, ACG don't think it's cool telling me stuff like that anymore, so they're not likely to help me in that quest anytime soon. But if there's anyone here that's interested in reversing firmware, again, I'd be very pleased to talk to you. It could be very useful. Any other questions? Yes, sir.
What do those white badges look like when you rip them open?
What does a white badge look like when you tear it open? Basically, you have an antenna going around the outside, which is a bazillion turns of the thinnest wire you've ever seen. There's a little chip and a condenser, and basically the condenser is storing the energy long enough, capacitor is storing the energy long enough to be able to operate the chip and do stuff.
Those are the really common ones, aren't they?
This is, well, the question was, is this a very common tag? The appearance of this tag is just known as a clamshell. There are a million different formats of tag that actually use the same physical standard, so you can't tell just by looking at it. There's an HID tag that looks like this. There's a Q5 high tag. In fact, if you go to my website, the RF Idiot site, rfidiot.org, there's a tag gallery there where I've got pictures of all the tags I see. And if you look at the Q5s, you see you can buy a Q5 in pretty much any format you want. So if you see a tag that looks like this that you want to clone, you could actually probably go and buy a Q5 that looks like this. So your clone will look identical to the original. Question is, are my Python scripts up there? Yes, RF Idiot is a tarball which you can download. Everything is on there. It's a central library with a bunch of test tools that you can do stuff like this with. I've renamed one of the tools for public consumption, which you can probably... Any other questions? Yes, sir. Can a Q5 be used to clone any type of tag? No, there are limitations. I was hoping I could clone an HID tag with a Q5 because in theory it should be possible. The problem is it doesn't have enough bit storage. There are some other problems, but I can't tell you, or I'll get rugby tackled off the stage by a patent attorney or something. So yeah, there are limitations. As long as the tag's using those parameters, then you could set the parameters. But finding out exactly what it's doing in the first place is quite tricky. You can do it with a spectrum analyzer, or, people are looking at this stuff with GNU Radio, for example. You get a lot of useful data back from GNU Radio. I'm not sufficiently low level to be able to do that, but I'm working with people who are, so hopefully we will have some tool that you can use to just stick a tag and it'll say, oh yeah, it's doing this. Here's a list of its parameters. Any other questions before I move on to high frequency?
Obviously, you have to have tags plus a reader in order for it to generate. But once you have that, then you work with distance broadcasting.
Question is, once I've got a tag in front of me, have I played with actually broadcasting that signal? Are you talking about doing a remote relay attack, for example? Yeah. I haven't done it myself. Some guys at Cambridge did it, and I've read their papers, and it's pretty simple. You build a device like the one I looked at the beginning, Jonathan Westhouse's device, and instead of just recording the signal, you transmit it by radio to another device which then plays it back. And that could be used to relay signals from, say, a payment card. So you stand next to someone in an underground station and you read his card out of his pocket and relay that signal to the gate, and the gate opens. You don't have to know what the signal is, you're just being man in the middle. It has been done, yes, but not by me. Okay, I'm going to move on to the next part of the talk, which is the smart cards. So how do you get around the problem of relying on unique IDs? Well, you use encryption, strong encryption. So the new passports and most of the payment card systems, they use strong encryption to protect the system. And so they should. There's some very interesting data on there. You've got 48 items of data on the new biometric passports, which will include the fingerprint. In 2010 in the UK, they'll start to include fingerprints. It already has your facial image, obviously the photograph, birth certificate, or whatever other document you use to actually get the device, the passport in the first place. And some other, pretty sensitive stuff, profession, home address, phone number, and so on. So obviously, if you're going to put all that stuff on a passport, you want to protect it. Oh, incidentally, one of the things that people often ask is, how do I tell if there's a chip in my passport? The clue is that there's this logo on the front. So that's an international standard. If your passport has that logo on the front, you have a chip in it. Some countries, there's a rather bigger clue, which is there's this damn great chip in it, which is true of the UK one. Many of them, it's hidden in the cover. You wouldn't be able to find it. I think the Australian passports have a really thick plastic page, so it's pretty obvious it's in there. So they've done a couple of things. They do the opposite of what the unique IDs do. So they don't want to have a unique ID. They don't want to be able to say, well, I've seen Joe Schmo's passport, so now I know his number, so next time I see that number, I know that Joe's in my vicinity. So what they're supposed to do is spit out a pseudo-random number, okay? So it will never give out the same ID twice. They use strong authentication, so although you can select it, you can't actually read any data out of it unless you know the key, and the key is based on 3DES. And that's part of a standard called Basic Access Control. And the important thing to understand about that standard is you don't have to use it. You can choose to have a passport. If you're a country that issues passports, you can choose to have a passport with no encryption on it. But if you want to have access control on it, you must use BAC, and that's based on 3DES. So the way it's done in every country is the same way, so that when you cross a border, they can read your passport. In addition to that, you can choose to encrypt the content of the passport. So you could use encryption to encrypt the actual files on top of the authentication. Unlike basic access control, there is no standard for how you do that. That's called extended access control, and it's entirely up to the issuing countries how they do that. I have not seen any passports yet that have any encrypted content. And I don't think this is going to be useful until they come up with a standard, because if you can't decode the stuff, what's the point in passing it around? So I think that won't happen until they've published a standard for how to do it. So if you're going to put all this sensitive data on your passport, obviously you want to protect it. 3DES is a symmetric key, so both parties need to know the key. So where do you put it? You print it on the passport, obviously. So where they print it is on the MRZ, the machine readable zone. You take the passport number, you glue that to the expiry date and the date of birth of the subject, and that's your key. So I'll give you a quick demonstration of reading a passport. Just have to reset my speed because the passport reader goes a bit faster. So again, this is an off-the-shelf ACG reader. Now normally you would hand your passport over and they would swipe it through a machine and it would read the MRZ, and that would be used to generate the key. I don't have one of those, so I've pre-typed it to save you all falling asleep while I do this. So I'm going to tell it, this is the machine readable zone, try and read this passport. So we've logged in, we've read some stuff. We're now reading one of the biometric files which contains the image. And that will then display once that's finished. So as you can see, I was a lot better looking when I had this picture taken. Actually, this is my son's passport. He's not allowed to travel when I'm speaking. So, it starts to get complicated. On this trip, he was in Estonia last week, and so I arranged to meet him at Gatwick Airport, and he was really pleased. He said, "Oh, that's so cool! You're coming to meet me." And I'm like, "Yeah, I'll meet you there." You're coming in at 8. I'm flying out at 10. No problem. We'll have a coffee. And so he lands, and I meet him, and I'm like, "See your passport a sec." "Great, thanks. See ya. Got to go." So, yeah, I have it, and he's back home and not going anywhere. So as you can see, we've got a picture. We've got not just a picture of the subject, we've got the actual picture that the authorities expect to see in his documentation. So if I was going to produce a fake passport, I've got everything I need there to do it. I've also got the signing certificate that was pulled off the passport. So this is the certificate. And I've got a bunch of other bits and pieces. These various files store things like, biometric, the standard biometric template. Once it's got fingerprints, it will have a picture of the fingerprint and a biometric analysis of what your machine should be expecting the real fingerprint to look like, and so on. So quite a lot of useful data in there. Once it's got everything else, the proof of identity document and so on, then this is obviously, an identity thief's dream. Everything's collected in one place for you. So one of the questions I often get asked is, okay, so you can read the stuff off the passport. Can you clone it? That's been proved, yes, you can. There's no anti-cloning mechanisms. You just copy the files, put them back on another passport, a blank passport, and you're done. But that's no good if you don't happen to look like the subject. So can you change it? Could you change the image and expect that to get through? It shouldn't be possible because each object is signed. Okay, so what you've got is a file which says this is the picture, and then that's signed, and then you've got another file which says these are the signatures, and you've got another file which is this is the key, the public key of the key that signed it. So can anyone spot the deliberate mistake there? the object and the thing you're checking it against are both delivered by the same physical medium. So what's to stop me rewriting the key, signing it with my own key and saying this is the correct key? So they've published a thing called the PKD, the Public Key Directory. That should, in theory, stop that happening, because you can now go and check that the key you've been given to check it against is actually a valid key. So that's a good thing. That only happened in April. These things have been out there for nearly 2 years now, or even longer, I think, in the case of some countries. So for a long time, it hasn't been possible to change the key. There's 28 countries currently issuing these. There's 15 countries, according to the ICAO website, participating in the PKD program. So there's still a lot of countries that they cannot actually check everyone's certificates. I would assume the US is a participant, but I don't know. I mean, it was the US that pushed this program through, really. They were also the last ones to issue the passports themselves because of security concerns, but, you know, who are we to judge? So I had a look before the PKD was available. I was looking at, you know, how difficult would it be to forge a certificate, and actually, obviously, not very. That's a New Zealand certificate taken out of a passport, and that's my copy of it. So if I flick between the two, you can see the only thing changing is the cryptographic modulus and the signature below and so on. So if you don't have a PKD, it's utterly trivial to produce a realistic-looking certificate and sign with it. So other threats. Again, one of the defences that came out early on, at least in the UK, was that, yeah, so what? You've read the data off a passport, but you already had the passport in your hand. What's the big deal? So I was actually challenged by a national newspaper to try and read a passport that I couldn't see the internal page. So they had someone apply for a passport, and then I went to their offices, and the person with the passport came to the office, and we had a sealed envelope, and I was able to find out the key data I needed and get into that passport within about 4 hours, because there is no brute force protection. I can try as often as I like to log in. It's just going to keep letting me do it. So if I can show you that. If I change, say, the last 2 digits of the passport number, so what I've done is just put 2 question marks there because I don't know those 2 digits, yeah? So it's going to try and log in, it's going to fail, it's going to try and log in, it's going to fail, and it'll keep doing that for a bit until eventually it gets in. So there is no anti-brute force mechanism, unlike a credit card, 3 strikes and you're out. Mobile phone, GIM's GSM card will lock you out if you get it wrong too often. Passport, I did 40,000 attempts to get into this passport, and I was in, so not a problem. However, that isn't really feasible unless you know a hell of a lot of the key space. It's just way too slow. So the problem here is not that it's... I knocked the passport, but as you saw, it did manage to log in. But so I got an OK authentication just before I whacked it with my wrist. So the problem is that the key space isn't strong enough. We can derive the key information from other sources. We can find out people's dates of birth. We can find out the passport number by doing analysis on the way passports are issued, and you can find out the expiry date of the passport if it's in transit from some clues on the envelope. I think a Dutch company called Riskier did an analysis of the Dutch system and worked out that they could brute force pretty much any arbitrary passport within about 4 hours on a standard PC, or 2 hours I think they got it down to, because their key space is so easily reduced. The other issue is profiling passports. So you can tell which country a passport came from, even if you can't read the actual data. So in a lot of cases, you can say, well, I don't know who this guy is, but he's American, or he's Australian, or he's Italian, or whatever. So there's an obvious threat there. And the reason you can do that is because each country has implemented the standard slightly differently. And instead of enforcing a rigid standard, they've allowed it to creep. And so there's a lot of different ways you can do it and still be within the standard. So every time someone does something different, the combination of differences tells you who they are. So again, you could build a bomb that only goes off when an Australian or an American or an Italian goes by, which I kind of think would be bad. So as I mentioned, the tools that I've used, all open source. It's written in Python. It's hardware independent, so I have an abstraction layer that talks to the actual reader device. I currently support ACG, Frosh, and PCSC devices using PCSC Lite. There's a project called OpenPCD, which is a completely open circuit design for an RFID reader. And we're currently working on that. They're actually going to make the low-level interface compatible with my slightly higher-level interface, so you can use RFIdiot to talk to it. It's all freely downloadable from there. I have a few devices with me, if anyone's interested, that I can show you, or if you want to acquire one, and I also sell them on the site. So, any questions on the high-frequency stuff? Yes, sir. Is my passport discussion in a white paper on the website? It's not, but it's about to be. Just before I came out, I wrote an article for a security magazine which covers most of what I've talked about here in brief. And what I'll probably do after that's published is expand on that. No other questions? Yes? Shielding. Yeah, different country. The question was, is there any shielding to protect the passport from unauthorized reading? Most passports have no shielding at all. The US passport has shielding in the cover, but it's such that if you drop the passport like this and it pops open slightly, it's actually acting as an amplifier. So it actually makes it easier to read from a greater distance. Yes, sir. I'm sorry, will it support?
Will the OpenPCD project passport low-end high-frequency tags or just
The OpenPCD project question was, which tags does it support? It's specifically the 1356 megahertz frequency tags. It's aimed at the ISO standard 14443A passports, MyFair, so on. Yes, sir.
So there are smart chips that have both the RFID interface and the standard content interface.
Yeah. The question was, have I tested against smart chips that have the standard chip interface as well as the RFID interface? Basically, if you take a smart card and you remove the physical contacts and put an RFID system and an antenna instead, everything behind is the same. You're talking to a smart card. When I read a passport, I'm using smart card standard commands to say, select this application, select this file, read the blocks off the file, and so on. So I think generally those devices will just have a dual path to the underlying chip. You could attack them from either way. Now I've implemented PCSC, the PC Smart Card standard. I am going to start looking at chips as well. So there's some interesting applications like chip and pin in the UK. An issue that often comes up for me, actually, is in the UK we use the chips. We don't use the mag stripes anymore. And so what happens is I don't notice when my mag stripe gets FUBAR'd. So I go abroad to somewhere where you don't use mag stripes, and my cash card doesn't work because the mag stripe's screwed, and I've never noticed because in UK we use the chip. There is a file on that chip which is an image of the mag stripe. So in theory I could read it off and re-blow my mag stripe for myself, which I have the tools, So I'm going to play with that because it would be handy. Yes, sir.
In the last slide, you said the Australian passport didn't allow file read, but allowed select. Can you just talk about that for a second?
Okay, so the question was about the way the Australian passport behaves. The standard says that you can you do basic auth at the point where the passport decides it wants to authorize you. So you connect to the passport. You select a unique application ID. The way smart cards work is every manufacturer has their own ID, or every program has its own ID. So there's the passport application is a unique ID that you select. So you say, select the passport application. If it's a passport, it will say OK. So you've already identified the fact you're talking to a passport and not a credit card or something else. You then say, select the master file. On a British passport, as soon as you said select the master file, it would say authenticate. On the Australian passport, it'll say OK. You then say read the master file. The Australian passport will say authenticate. On the British passport, you already authenticated. So it's just a difference in when it does things. And both of those approaches are legal according to the standard, so it'll just work. They haven't done anything wrong. Yeah. Yes, sir?
I have a ham radio that I've modified to transmit on 13.56 megahertz.
Right.
I just wonder what kind of trouble would that cause if I use that in an airport?
Okay, so would a ham radio broadcasting on 1356 megahertz cause a problem with the reader? It probably depends how much you're squirting through, but as I said at the beginning, I'm not a low-level guy. I would say there's other people here who understand the radio and the electronics much better. The 1356 tags actually do have a defense against that. They have anti-collision built into the standard. The lower stuff, the 125s, tend not to. So a certain three-letter manufacturer's reader, for example, who shall remain nameless, if you were to take one of their tags and break out the chip and glue it to the bottom of the reader at a 90-degree angle, say, you might just feel like doing that. It's possible that future tags wouldn't be able to read anymore because it's blocking the signal. It's just sending out a permanent signal to the reader, and the new tags will. So you can DOS a building with a 1 pound tag. And that probably applies to all the other standards as well. There's no anti-collision, so if you have two tags in the field, they won't read. But on the high frequency, you can have two tags in the field and they will read. Yes, sir? The paper-based, the cheapo paper-based ones are underneath the same format. The circuitry is very, very simple. It's just an antenna and a little chip embedded in it. So you see them all over the place. I mean, in fact, I think Gap now, any clothes you buy will have a little bit of cloth in which has an RFID tag built into it. Yes, sir? Have I looked at the debit cards? I've seen the new Amex, and it follows the ISO 14443A standard. So I can read it. I have a device that will clone the ID. Actually, I can show you that. This is a commercial piece of test equipment. It's actually designed for testing readers. So it's a smart card emulator. And what it is the circuitry for doing the RFID plus an FPGA. So you program the FPGA to provide the smart card application or whatever else you want to do. And it will, in its default state, it will just spit out an ID and nothing else. So if those micropayments are being based on purely the unique ID, then they've used the new technology that's capable of doing all the crypto and everything in the dumb card way. Ironically, a certain three-letter manufacturer who shall remain nameless has got a new standard system which is using an ISO standard, so they can't throw patent attorneys at you if you do stuff because it's a standard. And their new ones some of them are susceptible to that kind of cloning attack as well because they haven't used the crypto functions on the cards. So a step backwards, I think. Yes, sir? Does the industry understand the implications of this? That's always a hard one to say. I mean, the reason I believe in full disclosure, because what the industry understands and what the industry does are usually two completely separate things. And full disclosure is a helpful tool in enabling them to better understand why they should behave differently and make changes. I mean, it's obvious that the manufacturers of the tags like the Q5 and the high tag, they must know that you can program any ID you want into that tag. So on the one hand, they're telling consumers these tags are super secure and cannot be cloned, and on the other hand, they're telling people within the industry, suppliers, here are our tags which you can easily program to any ID you like. So the two are not compatible. So I think it's the usual thing. It's a money thing. Any other questions? Yes, sir.
You were using the small compact flash reader for both low bands and high.
I have two different models of compact flash reader, but yes, they are available for both. The ones I build and sell are USB-based external boxes with bigger antennas. And you'll probably find there are other manufacturers who are using the same components that my software would be compatible with, and I would be happy if anyone comes across one, I'll be happy to add them to the list on the site. I don't build them to make money, I build them because they're hard to find, and I can only get the components in the UK. So if I'm going to build one, I might as well build 10, you know. Yes, sir. Do I have any tools for permanently disabling RFID chips? I don't, but I did write a little program which basically hides my Q5. So it's called Q5 Stealth. Wrong tag. So that's basically programmed it into a completely nonsensical mode. So if I try and scan it, it's not going to read. So it's not completely hidden, but it's currently disabled. Yeah. No more questions?
Easier way you can disable your passport.
Is there any easier way you can disable your passport chip? Or permanently disable it? Yeah. You can whack it in a microwave. That causes a little bubble, which is probably will be spotted as you cross the border. Having a broken chip should not stop you crossing the border. It actually says that in the standard. However, and probably what will happen is they'll replace it the first time. If they catch you doing it a second time, they might start to get suspicious and you'll have to pay to replace it yourself. And third time, they may take further action. You know, passport doesn't belong to you, generally, it belongs to the state. I've heard a sharp rap with the heel of a shoe works quite well. Alternatively, you know, the tinfoil hat brigade got this one right. You can just wrap it up in tinfoil and it'll be fine. Okay, I think we'll wrap it up there, so thank you.